Hello everyone. In this particular video, today we're going to be solving AQA GCSE Chemistry Foundation. Today we're solving June 2021. This is the part 1 of the question paper where we're going to be solving from question number 1 to question number 5. This question is about Earth's atmosphere. How long was the Earth formed? We know that the Earth has formed 4.6 billion years ago. So 4.6 billion years will be the answer. Table 1 shows the percentages of gases in the atmosphere of Mars and Earth today. Carbon dioxide 95.97, Earth 0.04. So these are the percentage of gases in Mars and Earth is given here. Calculate the percentage X of other gases in the Earth's atmosphere. So when it comes to other gases, we just need to remember the total is equals to 100. 100 minus 78.09 minus 20.95 minus 0.04. The remainder will be 0.92%. The atmosphere of the early Earth is thought to have been similar to the atmosphere of Mars today. The percentages of nitrogen and of oxygen in the Earth's atmosphere today have changed from the percentage in the Earth's early atmosphere. Draw one line from each gas to the change in the percentage of that gas. Nitrogen. So we can see nitrogen is 2%, and here on Earth is 80%. So it's like 40 times increase. Oxygen, all right. Oxygen in the Mars atmosphere is 0.15 and Earth's atmosphere is 20.95. So that increased by 21%. The percentage of carbon dioxide in the Earth's early atmosphere decreased. Which two processes caused this decrease? To decrease carbon dioxide concentration in the air, photosynthesis can play a vital role. So photosynthesis, or the carbon dioxide may dissolve in seawater. This can also happen, all right? And then formation of sedimentary rocks. Sedimentary rocks contain calcium carbonate or other carbonates, which can then trap carbon dioxide in it. Photosynthesis also decreased the percentage of carbon dioxide in the Earth's early atmosphere. Photosynthesis increased the percentage of another gas. Complete the word equation for the photosynthesis. So carbon dioxide reacts with water to produce glucose and oxygen. Scientists are not certain about the percentages of gases in the Earth's early atmosphere because there is a lack of information generally, because these are from like very, very long, very, very early times, all right? And we did not, even though we have a little bit of information which we are actually deriving, we do not have any proof. So evidence or proof. This question is about water. A student investigated the concentration of salt in seawater. This is the method used. Filter the seawater to remove sand. Measure the mass of an empty evaporating dish. Measure 50 cm³ of seawater in the evaporating dish. Heat the evaporating dish and seawater. Evaporate the seawater to dryness. Measure the mass of evaporating dish and salt. What equipment should the student use to measure the mass of the evaporating dish, the volume of the seawater? To measure mass, we can use a top pen balance or an electronic balance, and volume can be measured using measuring cylinder. Table 2 shows the student's result. Evaporating dish 30.44, evaporating dish with salt 30.49. So we can see 0.05 grams of salt. The student used 50 cm³ of seawater. Calculate the mass of salt in 1000 cm³ of seawater. Alright, to find this particular answer, first of all, we will find out the mass of salt first, which is 0.05 gram of salt. Then mass of salt in 1000 cm³ will be equals to 1000 divided by the 50 that we have selected from here from the seawater. All right, 1000 divided by 50, the answer will be 20, and then we'll multiply that with the amount of salt that we have received in 50 cm³ of seawater, which is 0.05. This is equals to 1 gram. The salt must be completely dry. Which two extra steps are needed to show that the salt is completely dry? In order to show that the salt is completely dry, we must reheat the evaporating dish and measure the mass of the evaporating dish and the salt again. So heat the evaporating dish and salt again. Once we did that, then we will measure the mass of the evaporating dish and the salt again. If the mass remains consistent, then we can say that all the water has been completely dried off. Two students Y and Z distill seawater to collect water. Figure 1 shows the apparatus used by each student to collect the water. Student Y, steam from boiled seawater. Water collected. Student Z, steam from boiled seawater. All right, we can see in the condenser, cold water coming in, water is getting out, and then water is collected. In the second setup, we collected more water. Student Y and Z boil the same volume of seawater for the same period of time. Explain why student Y collects a smaller volume of water than Z. Since the student Y did not use any condenser, so more of the steam escapes because they were at a higher temperature. And because, cooling is less efficient in the setup for student Y. Water obtained by distillation does not need to be sterilized and is safe to drink. Suggest why. Distilled water is pure water, so it does not contain any impurities. That's why it can be safe to drink. Fresh water needs to be sterilized before it is safe to drink. How is fresh water sterilized? Fresh water can be sterilized using chlorine. Chlorine kills bacteria, and we can use ozone. Ozone is also able to kill bacteria in water. A student tests the pH of fresh water using universal indicator solution. When added to fresh water, the color of the universal indicator solution is green. What is the pH of the fresh water? Green indicates a pH of 7. This question is about substances used to make windows and window frames. Figure 2 shows a window. So you can see the frame, glass. Glass is made by heating sand with 2 other materials. Which 2 other materials are used to make glass? So glass requires limestone and glass also requires sodium carbonate. Window frames need to be easy to install, resistant to damage. The polymers polychloroethene and HDPE are used to make window frames. Table 3 shows information about polychloroethene and HDPE. Density and relative strength for both of the substances are provided. Suggest one advantage of using polychloroethene compared to HDPE to make window frames. So the advantage we can see that polychloroethene has relatively higher strength. So since it is stronger and thereby there is a chance that it will less easily get damaged, Suggest one advantage of using HDPE compared with polychloroethene to make window frames. Give one reason for your answer. You can see that HDPE is, it has less density, so the material is going to be more lighter. Figure 3 shows the displayed structural formula of polychloroethene. Which monomer is used to make polychloroethene? To derive a monomer from polymer, we will first of all, take off the 2 hands from both sides and make a double bond in the middle. Then we're going to search for the substance. Chlorine gas is used to produce polychloroethene. Describe test to identify chlorine gas. So chlorine gas can be detected by using a damp litmus paper. It can be of any color, no problem. The damp litmus paper gets bleached and it turns white. Wood can be used instead of polymers to make window frames. Polymers are unreactive. Polymers are produced from crude oil. Wood breaks down in wet conditions. Wood is produced from trees. Suggest one advantage of using polymers and one advantage of using wood to make window frames. Advantage of polymers. So since polymers are unreactive, they are going to be very long lasting. And for wood, the advantage would be that it is renewable, and as long as we have trees and plants, we are going to get wood. Window frames can also be made from an alloy of aluminium. 6 kg of the alloy is used to make a window frame. Table 4 shows the mass of each element in 6 kg of the alloy. Calculate the percentage of aluminium in 6 kg of the alloy. So the mass of aluminium 5.94 divided by 6 into 100%. So 99% is aluminium. Why is an alloy used instead of pure aluminium to make window frames? Alloys are harder than pure aluminium, so they're more durable. This question is about reaction between gases. When hydrogen gas is heated with iodine gas, hydrogen iodide gas is produced. The equation is reversible, hydrogen plus iodine. The reversible symbol in between, and hydrogen iodide. The reversible reaction reaches equilibrium in a sealed container. How does the equation show the reaction is reversible? So the equation contains a reversible sign, which indicates that the reaction is reversible. Which 2 statements are correct when the reaction reaches equilibrium? The forward reactions and reverse reactions are both exothermic. No. If the forward reaction is exothermic, the backward reaction must be endothermic. The gases have escaped from the container. We can only reach equilibrium in a sealed container. The hydrogen no longer reacts with iodine. We know that the reaction keeps on going on. Hydrogen reacts with iodine and produce hydrogen iodide. However, some hydrogen iodide that has formed before, they break down and form hydrogen iodine back again. So the reaction goes on. The mass of each substance does not change. This is correct. The rate of forward reaction and reverse reactions are equal. This is correct. The initial mixture of hydrogen and iodine in the sealed container is purple. Hydrogen iodide is colorless. How will the color of the mixture in a sealed container have changed when equilibrium is reached? Because the purple color will slowly disappear, the mixture will become a paler purple. But it will not completely disappear because there will be some iodine left even at equilibrium. The rate of reaction between gases is affected by changing the pressure. When the pressure of the reacting gases is increased, the rate of reaction will increase. So when we increase pressure, it acts as if it is high concentration. So at higher pressure for gases, it's like higher concentration for aqueous solution. Okay, so there is more reactant particle, they collide more often and thereby leads to faster reaction. This is because at higher pressure the distance between particles are definitely going to be less, so we're going to say decreases. This means that the frequency of collision obviously increases. Give one other way of changing the rate of reaction between gases. You should not refer to pressure in your answer. Okay, so we can increase the rate of reaction in any experiment by increasing temperature, all right, or by adding a catalyst. A student investigated the rate of reaction between zinc and sulfuric acid. Pour 40 cm of sulfuric acid in a conical flask. Add 2 grams of zinc powder to the conical flask. Put the stopper in the conical flask. Measure the volume of hydrogen gas collected every 30 seconds for 5 minutes. Here we have a delivery tube, stopper, conical flask, sulfuric acid, zinc powder. We can see everything. You can see a mistake in the diagram. The delivery tube is inside the liquid. X shows where a piece of equipment is connected to measure the volume of hydrogen gas collected. Complete figure 4 to show the equipment. In a diagram like this, you can add a gas syringe. You can add a collection over water method. A gas syringe is convenient. A gas syringe is usually graduated. So show the graduation. All right. And then label gas syringe. The student made an error setting up the delivery tube shown in figure 4. Describe the error and the problem this error would cause. So we already detected the error. The error was the delivery tube was in the sulfuric acid. And the problem that it would cause is that the sulfuric acid will travel up the tube, so gas will not be collected. The student then set up the apparatus correctly. Figure 5 shows the student's result. Complete figure 5 by drawing the line of best fit. When we are asked to draw the line of best fit, all we have to do is we try to go through all the points and try to make a smooth line as possible. Now this device has a little bit of auto correction, so we're trying to use that. Determine the mean rate of reaction between 0 second and 60 second. Guys, be very careful. Always this question comes within a specific time range. So extrapolation is required. Extrapolation is when we, extrapolate the time that the volume produce within that particular time. Each box represents 2, so this will be 45. Mean rate of reaction is calculated by volume of gas formed divided by time taken. The unit will be volume divided by time, so cm cube per second. Now, to find out the mean rate of reaction, we are going to divide 45 with the time taken, which is 60 seconds. And the answer will be, and the unit will be cm cube per second. The student repeated the investigation using sulfuric acid of higher concentration. The student plotted the results and drew a line of best fit. How would the student line of best fit for higher concentration compare with the line of best fit for lower concentration? The line of best fit for higher concentration would have less steep slope. We know that at higher concentration, the reaction is faster. So it must have a higher steep slope. So this is a wrong statement. The line of best fit for higher concentration would have a steeper slope. This is correct. So guys, in this particular video, we're done with question number 5. Thank you for watching the video. And guys, keep an eye for the, second part of the video where we're going to be loading from question number 6 to question number 10. All right. Thank you for watching the video. Best of luck with your exam. See you in the next video. Bye-bye.